Imagine you're standing at the edge of a hole on Earth, then dropping a rock down into it. You wait 1 second, then 2 seconds, then 10 seconds, and almost a minute later, you finally hear the sound of impact echoing up from the deep bottom below. Sounds like science fiction, right? But the strange thing is that hole is completely real. It's not a natural cave, nor a giant mining pit, but the deepest man-made borehole ever created by humans on this planet. It's called the Kola Super Deep Borehole. And what fascinates me the most is not just its astonishing depth, but what the scientists found when they started looking deep down below the Earth's crust. Because the deeper they drilled, the more they realized that perhaps we understand very little about the world right beneath our feet. To understand why humans created that strange hole, we have to go back to 1970, right in the middle of the Cold War era, when the Soviet Union and the United States were competing with each other in almost every imaginable field of science. Most people remember the space race, rockets, and the moon, but there was another race that was mentioned far less. And honestly, I've always found it just as fascinating. It was the race to go down into the Earth. The Soviet Union decided to start a project without precedent, to drill as deep as possible into the Earth's crust. The interesting part is they didn't do it to find oil or gold or anything like that. This was almost pure science, an effort to answer a very basic but extremely difficult question. What is really beneath our feet? The chosen location was the Kola Peninsula, located above the Arctic Circle, a cold, desolate place that contains one of the deepest sections of continental crust on the planet. Geologists believed that if you wanted to look into the deep history of the Earth, this was the perfect place to start. The drilling system they built was truly enormous. I often think of it as a metal building being constructed upside down into the Earth instead of toward the sky. Kilometers of steel drill pipes were connected together into a column of astonishing length, hanging straight down like a giant metal cable. The problem was the entire system had to withstand the tremendous weight of its own structure, not to mention the increasing temperature and pressure the deeper it went. Just one small mistake and the whole chain of equipment could shatter, and that did happen. In a serious accident, about 5 kilometers of drilling equipment broke off and was lost forever deep underground. Imagine spending years as building a giant machine, only for a large part of it to be swallowed by the very planet you're trying to study. What's amazing is they didn't give up. The research team decided to drill again from a lower depth and continued the work for 24 continuous years. Many engineers basically devoted their entire careers to drilling a single hole. In the end, they reached a depth of more than 12 kilometers, precisely 12,262 meters, the deepest point in human history. What made the Kola project truly special wasn't just depth, but what began to appear as humans went deeper and deeper below the planet's crust. The scientists entered this project with quite a lot of confidence. They believed they already understood the structure of the Earth relatively well, thanks to seismology, earthquake, wave analysis, and decades of geological research. The general idea at the time was fairly simple. The deeper you go, the more the rocks would change according to patterns that science had already predicted. But nature quickly began telling them something very different. One of the first shocks came at a depth of about 7 kilometers, when the research team discovered water inside the deep rock layers. Now, that might sound normal if you simply think that water is always underground, but here's what's strange. At that depth, the pressure and temperature should have been so great that every crack in the rock would be squeezed shut. According to the models of the time, there should have been almost no space for water to exist in liquid form. Yet, the water was still there. I've always liked moments like that in science because they serve as a reminder that nature doesn't care at all about what humans think should be true. It turned out that the water wasn't rainwater that had seeped down from the surface as many people might imagine. Scientists believe it was created directly inside the rock when hydrogen and oxygen were squeezed out of minerals under extreme pressure. In other words, the rock itself was producing water in some way. And honestly, if you stop and think about it for a moment, that's pretty crazy. We usually think of rock as something dry, hard, lifeless, and completely static. But deep underground, matter begins to behave in ways very different from our surface intuition. Then things got even stranger when scientists discovered traces of fossils from ancient microorganisms lying kilometers deep underground. Imagine that for a second. Tiny organisms that once lived on the ocean floor millions of years ago are now buried deep inside the ancient rock layers of the Earth. like time capsules locked away from prehistoric times. Studies showed that more than 20 species of fossilized microorganisms were found in the deep rock samples. This helped scientists understand that the area now lying under the Arctic ice sheet was once the bottom of an ancient ocean hundreds of millions of years ago. And then they found another surprise. Some of the deep rock layers contained much higher amounts of gold than predicted. Not the mountain of gold, kind like in adventure movies, but enough to make geologists ask additional questions about how elements are distributed beneath the planet's crust. However, the biggest shock was still ahead. For many decades, scientists believed that at around 7 kilometers deep, the granite layer would end and transition to basalt. The entire model was based on seismic wave data from earthquakes. Those signals indicated that the material below must change at a certain depth. But when they drilled down, the granite layer continued even deeper. No basalt appeared as predicted. It was like opening a book you were sure you knew the ending to, only to discover that the entire next chapter was completely different. This was the moment that made many scientists realize that studying the Earth from the surface is much harder than imagined. We are really trying to infer the structure of an entire planet just from vibrations passing through rock. And sometimes those vibrations mislead us. This also opened up a much bigger question. If we can still be wrong about the crust right beneath our feet, then what about even deeper inside? Because Earth isn't just the rock layer where we live. Below the crust is the mantle, a huge ocean of hot rock moving extremely slowly. Even deeper is the outer core of liquid metal and the inner core, which is solid and as hot as the surface of the sun. But this is the part that always makes me feel the most humble. After 24 years of continuous drilling, after all the giant machinery, money, engineers, and technology that humans could create, we had only touched the extremely thin outer part of the planet. If you shrank the Earth down to the size of an apple, the Kola borehole wouldn't even have pierced through the apple's skin. It was just like a tiny scratch on the surface. And what's truly astonishing is that humans have sent spacecraft to Mars, sent probes outside the solar system. But to this day, no one has ever directly seen the mantle layer right beneath our feet. Now, to truly understand why the discoveries at Kola left the scientific community so puzzled, we have to talk about something that normally almost no one thinks about: pressure. Let's start with a very familiar experience. If you've ever dived deep into a swimming pool or the ocean, you've probably felt your ears hurt or get squeezed. That happens because pressure is increasing around your body. Even right now, as you're sitting reading or listening to this story, you're also under atmospheric pressure from the entire column of air above your head. We don't feel it, only because our bodies have gotten used to it since birth. But air really does have weight. The entire atmosphere of the Earth is pressing down on us all the time. At sea level, that pressure is about 14.7 pounds per square inch. It might not sound like much, but if you add it up over your whole body, you're under tons of force pressing down from the surrounding air. The interesting thing is we don't get crushed because the pressure inside our bodies balances with the pressure outside. Now imagine what happens when you go down into water. Water is much denser than air, so pressure increases extremely quickly. Just diving a few meters, your ears already start to feel uncomfortable. Go deeper and the pressure becomes truly dangerous. Deep sea divers need special equipment because the human body simply isn't designed to withstand that enormous pressure. But this is the part that makes everything at Kola insane. Rock is much denser than water. That means when you go deep down below the Earth's crust, pressure increases to a level that is almost unimaginable. After the first few kilometers, everything starts to change. Try to visualize this in the most intuitive way possible. If the drill bit is at a depth of about 10 kilometers, above it are kilometers of solid rock pressing down with enormous weight. It's not just a few boulders. We're talking about the entire planetary crust pressing down on a steel column kilometers long. That's why many scientists at the time believed water couldn't exist at the depths where Kola found it. According to ordinary logic, pressure that great should crush every crack in the rock, leaving no space for water to exist. But nature did something else, and I've always liked that. Nature often behaves as if it enjoys confusing scientists. What's amazing is that pressure doesn't just affect the rock, it also affects the entire drilling system. The giant steel pipes began to bend slightly, twist, and deform over time. Things that look rock solid on the surface start behaving very differently under extreme conditions. This is the part where human intuition often fails. We grew up on the Earth's surface, so we think rock is hard, stable, and almost unchanging. But the deeper you go, the more the Earth resembles a living system rather than a dead block of stone. At high enough temperatures and pressures, matter begins to behave in strange ways. Rock is no longer completely brittle, it can bend slowly. Some minerals change their crystal structure. Cracks open and then close again under enormous pressure. That's also why the cola engineers kept running into problems with the borehole deforming. They weren't just drilling into rock. They were trying to drill into a constantly changing environment under extreme physical laws. This reminds me of something very important in science. Humans often think nature is much simpler than it actually is. We create models, formulas, and hypotheses, then start believing we understand the system. But when you reach the limits of physical conditions, nature starts doing strange things that everyday intuition no longer applies to. On the surface, rock is hard. Kilometers deep, rock can behave like a ductile material. On the surface, water flows freely. Deep down, water can be locked inside minerals for hundreds of millions of years. On the surface, steel is extremely strong. But under enormous heat and pressure, even steel begins to fail. That's why I think cola wasn't just a drilling project. It was like a direct confrontation between humans and the physical laws of the planet itself. The deeper they went, the more the engineers realized they weren't really conquering the Earth. They were just trying to survive in an environment that nature had controlled for billions of years before humans appeared. There's a question that I think almost anyone who has studied science has asked themselves at least once. If the Earth has existed for about 4.5 billion years, why is its interior still hot? It sounds simple, but this is actually one of the most interesting questions about our planet. According to ordinary intuition, everything heats up and eventually cools down. If you heat a metal rod until it glows red and leave it outside, it will gradually lose heat. A hot cup of coffee eventually cools to room temperature. So why does an entire planet still retain its enormous amount of heat for billions of years? To understand that, we have to go back to the time when the solar system was very young, when the Earth wasn't yet a green world with oceans and trees, but a chaotic mass of material forming in space. In that era, countless rocks, dust, and small celestial bodies constantly collided with each other. Each collision released an enormous amount of energy in the form of heat. Imagine holding a lump of clay and repeatedly hitting it with a hammer. It heats up. Now scale that up to a planetary level. Celestial bodies the size of mountains, or even larger, slammed into the young Earth at speeds of dozens of kilometers per second. Each impact was like a giant explosion that melted the entire planet. In the early stages, the Earth was almost a vast ocean of liquid rock. Heavier materials like iron and nickel began to sink toward the center under gravity, while lighter materials rose to the top. That very layering process also generated more heat. In other words, the Earth wasn't just born hot. It was hammered hot continuously by the early solar system. But then the next question arises. If the Earth was that hot, why hasn't it completely cooled after billions of years? This is where we have to talk about how heat moves in nature. There are actually only three basic ways for heat to transfer. The first is conduction. If you put one end of a metal spoon in boiling water, the other end will gradually heat up because energy travels through the material. The second is convection, when hot material moves and carries heat with it, like boiling water in a pot. The third is thermal radiation, meaning heat is emitted in the form of electromagnetic waves. The sun heats the Earth this way. Now imagine a glowing red-hot metal ball just taken out of a furnace. At first it shines and is extremely hot, but over time it gradually cools because it loses heat to the surrounding environment. Our intuition often thinks the Earth should be like that too. But there's a very big difference. Space is a near-perfect vacuum. There's no air to transfer heat efficiently like on Earth. That means our planet can only lose heat to outer space mainly through thermal radiation, and that process is extremely slow. On top of that, the Earth's crust acts like a giant insulating layer. It keeps most of the heat locked inside the planet for billions of years. I've always found this truly strange. We walk on a thin layer of rock that seems stable, but below it is an entire hot, constantly moving world. However, this is still not the whole story. If the initial heat was the only source, the Earth would probably have cooled more than it has today. Inside the planet, there is another heater that has been working continuously for billions of years. That is radioactive decay. Radioactive elements like uranium, thorium, and potassium deep inside the Earth continuously decay and release energy in the form of heat. The interesting thing is that the heaviest elements tended to sink deeper during the time when the Earth was still molten. That's why the core and mantle contain quite a lot of radioactive material. Each decaying atom only produces a small amount of heat, but when you add up billions upon billions upon billions of atoms over billions of years, the result is an enormous planetary heat source. In a sense, the Earth's core is like a natural furnace quietly operating from ancient times until now. This leads to an idea that I've always found wonderful in science. The planet beneath our feet is actually still vibrant. Not alive in the biological sense, but a giant physical system that has never truly rested. The mantle is still moving. The outer core is still swirling like an ocean of liquid metal. Magnetic fields are still being generated. Volcanoes are still erupting. Continents are still drifting slowly. We often think of the Earth as a fixed stage for human life, but in reality, that stage is constantly changing. And this is where everything comes back to the Kola borehole. The engineers initially predicted that temperatures deep down would increase at a certain rate. But the deeper they drilled, the more they discovered that the planet's interior was much hotter than expected. At a depth of more than 12 kilometers, the temperature had exceeded about 180 degrees C. The rock began to behave strangely. The equipment endured enormous pressure. The borehole kept deforming. In the end, it wasn't a lack of determination that made humans stop. It was the enormous heat accumulated inside the planet over billions of years that forced them to halt. As the engineers continued drilling deeper into the Earth's crust, the temperature at the bottom of the hole began to rise much faster than any initial calculations. They had predicted that the temperature at the final depth would be around 120 degrees C, which was already extremely harsh for mechanical equipment. But as they approached a depth of more than 12 kilometers, the actual temperature exceeded 180 degrees C. Now, try to imagine that for a moment. This wasn't the temperature inside a kitchen oven. This was a temperature existing under the enormous pressure of kilometers of rock above, in an environment where almost every material begins to behave differently. And this is the part I find very interesting because human intuition becomes almost useless under such conditions. We usually think of rock as something hard and stable, but at the extreme temperatures and pressures deep underground, rock no longer behaves like the rocks you see on the surface. It doesn't completely melt like lava, but it begins to behave like hot plastic or soft taffy. That might sound strange, but that's really how many geologists describe it. Imagine you're trying to keep a narrow hole open inside a block of hot material that's slowly squeezing back around you. That's exactly what happened with the Kola borehole. The deeper they went, the more the walls of the hole were pressed and deformed by the surrounding rock. The equipment started getting stuck. The drill bits bent slightly. The steel components bearing enormous loads over many kilometers gradually lost stability. The scariest thing for the engineers wasn't a big explosion or a sudden earthquake. What defeated them was the slow and relentless force of the planet itself. The Earth simply began to squeeze the hole closed over time. The extreme heat also destroyed the drill bits much faster than predicted. The constant frictions between metal and rock under extreme conditions caused the materials to degrade rapidly. The drilling fluid pumped down to cool and reduce friction began to work less effectively as the temperature rose too high. The electronic systems and sensors had constant problems. There were times when the research team almost had to fight for every single meter to continue going deeper. What I like most about this whole story is how very human it feels. You can imagine those engineers standing in the freezing cold of the Arctic region, looking at the giant equipment they had spent decades building, and realizing that the planet beneath their feet was gradually destroying everything they had created. And what's amazing is that they kept going. They kept drilling even though the temperature was higher than predicted. They kept drilling even though the equipment kept breaking down. They kept drilling even though the rock began behaving in ways that previous scientific models couldn't fully explain. But in the end, they had to face a very simple truth. The technology of that time could not go any deeper. This is the point where I think science becomes the most beautiful, because sometimes the most valuable thing isn't victory, but discovering the true limits of nature. Kola showed that drilling deep into the earth is much harder than our intuition suggests. Most people think, just keep drilling. But physics doesn't work that simply. Every material changes its properties when temperature and pressure increase enough. Steel no longer retains its hardness. Rock is no longer brittle like on the surface. Liquids change their behavior. Even the tiny voids inside the rock layers transform continuously under enormous pressure. At times, the deep rock began to flow very slowly around the borehole, almost like thick honey, slowly filling a gap. Think about that for a moment. A planet made of hard rock can behave like a liquid if conditions are extreme enough. That's the kind of truth I always find wonderful in physics and geology. Nature doesn't care what human intuition thinks is reasonable. It only follows the laws of physics. And when we push ourselves to the limits of those conditions, the world begins to become very strange. What makes this whole story both magical and a bit heartbreaking is that after 24 years of effort, after all the machinery, resources, and intelligence that humans could gather, we still couldn't reach the mantle beneath the planet's crust. We stopped right at the threshold of a deeper world that no one had ever seen directly. In a way, Kola was like the moment humans knocked on the door of the Earth and realized that door was much heavier than imagined. But honestly, I don't see it as a complete failure. I think it's one of the most beautiful examples of science. Humans went as deep as they could, discovered unexpected things, and were finally forced to stop by the planet itself. And even when they stopped, we still learned far more than we knew before. This leads us to an even bigger question. What does the inside of the Earth really look like? Most people, when they were children, imagined this planet as a giant solid rock ball. Honestly, that intuition is completely reasonable, because everything we see around us is hard, solid ground and rock. But the reality inside the Earth is much more complex and strange. The first thing to understand is that the surface layer where we live, the Earth's crust, is actually extremely thin compared to the size of the entire planet. I've always liked using the apple example for this. If the Earth were the size of an apple, the crust, where all the oceans, mountains, cities, and the entire history of humanity exist, would be only as thick as the skin of that apple. Everything we've ever built, every war, every civilization, every creature that ever existed, all of it lies on such an astonishingly thin layer. Below that crust is the mantle, which makes up the vast majority of the planet's volume. And this is where everything starts to become counterintuitive. When hearing the word mantle, many people imagine a bright red ocean of liquid magma, like in science fiction movies. But the mantle is not completely liquid. It's also not completely solid like surface rock. In reality, it's like a giant ductile material moving extremely slowly under enormous pressure and temperature. If you looked at the mantle for a few seconds, it would seem solid. But if you could observe it over millions of years, you would see it flowing slowly like thick honey. And it's that slow movement that drags the tectonic plates on the planet's surface around. In other words, the continents aren't really standing still. They are drifting on a vast ocean of hot rock that we cannot see. I've always found this truly wonderful. Even the ground beneath our feet is not as stable as our daily intuition makes us think. Going deeper beneath the mantle is the Earth's outer core. This is a layer of liquid metal, mostly iron and nickel, that is constantly moving around the inner core. And this is the part where physics starts doing something extremely beautiful. The movement of the liquid metal in the outer core acts like a giant generator for the planet. It creates the magnetic field surrounding the Earth. Without this magnetic field, solar wind and cosmic radiation would continuously bombard the planet's surface. The atmosphere could gradually be stripped away over time, just like what happened to Mars. In a sense, life on Earth exists in part because deep inside the planet, there is a swirling ocean of liquid metal. Just that idea alone is enough to amaze me. But the journey isn't over yet. At the center of the planet is the inner core, a giant solid ball of metal that is nearly as hot as the surface of the sun. What seems contradictory is why a place that hot is solid instead of liquid. The answer lies in pressure. The pressure at the center of the Earth is so great that it squeezes the atoms tightly together and keeps the inner core solid despite the extreme temperature. This is a great example of how our ordinary intuition almost stops working under extreme conditions. On the surface, high temperature usually makes matter melt. But at the center of the planet, the pressure is so great that it completely changes how matter behaves. I often think of the Earth's structure as a giant onion with many different layers surrounding the center. The only difference is that each layer operates under slightly different physical laws depending on temperature and pressure, and this is the part that makes the cola story truly humbling. The deepest borehole in human history, a project that humans spent decades creating, hadn't even reached the mantle. It had only gone through a portion of the thin outer crust of the planet. We often talk about going into the heart of the Earth, but in reality, we've only scratched the surface of the Earth. What's even more astonishing is that most of what we know about the planet's interior doesn't come from seeing it directly. We've never seen the mantle with our own eyes, never touched this outer core, never taken samples from the inner core. Most of our knowledge comes from analyzing seismic waves created by earthquakes. When an earthquake occurs, waves travel through the planet and change speed depending on the type of material they pass through. Scientists are like doctors trying to understand the inside of a body by listening to signals rather than looking directly. And sometimes those signals mislead us, just like the granite at Kola showed. That means there is still a lot we don't know. Honestly, I think this is one of the most beautiful things about science. We have lived on this planet for millions of years, built civilizations, sent spacecraft outside the solar system, but the deep part beneath our feet is still almost an alien world. In many ways, humans understand the surface of Mars much better than the deep interior of the very planet we live on every day. The strange thing is that almost everything I just told you about the inside of the Earth doesn't come from humans actually seeing it. We have never directly gone down to the mantle, never touched the outer core, never drilled to the inner core. Honestly, humans are almost completely blind to most of our own planet. So how do scientists know what lies thousands of kilometers deep below? This is the part I've always found extremely beautiful in science, because instead of looking, we learn to listen to the earth. Think about how you know there's someone in the next room even without seeing them. You might hear footsteps, a door closing, or sounds echoing through the wall. The brain starts to infer something it can't observe directly. Seismology works almost the same way. When an earthquake happens, the entire planet shakes and creates seismic waves that travel through the earth. These waves move like sound traveling through air, except they pass through rock, metal, and the deep layers of material inside the planet. Some waves can pass through solids. Some cannot pass through liquids. Some are reflected. Some change direction or speed. And from those small changes, scientists begin to build an invisible map of the Earth's interior. I've always loved this idea because it's like trying to understand the structure of an entire building just by listening to echoes from inside. If seismic waves suddenly slow down, that could mean the material below is softer or hotter. If the waves disappear completely in some region, that could indicate there is liquid there. It was precisely this way that scientists discovered the Earth's outer core is liquid metal. No one saw it directly. We inferred it from the behavior of seismic waves. In many ways, the entire model of the Earth's structure is a giant physics problem solved using indirect signals. And this is exactly where the cola story becomes extremely interesting. Before this project began, the geology community was quite confident about many of its seismic models. They believed that changes in seismic wave speeds accurately reflected changes in the type of rock below. That's why they predicted the granite layer would end at around 7 kilometers and transition to basalt. The seismic signals seemed to say so. But then cola drilled down, and basalt did not appear. The granite continued much deeper than predicted. Pause for a moment and think about that. A model built from decades of scientific data suddenly was no longer completely correct just because of one small hole on a cold peninsula in the Arctic. I truly love moments like that in science. Not because the scientists were wrong, but because that's exactly how science works best. Science is not a list of unchanging truths carved in stone. It is a continuous process of correcting itself when new data appears. I think many people misunderstand this. They think that if a scientific model changes, it means science is getting weaker. In fact, the opposite is true. Science's greatest strength lies in its ability to self-correct. When nature provides new evidence, the model must change accordingly. Nature has no obligation to behave according to what humans expect. And I've always liked to say that nature has the right to reject any beautiful model we create. You can write a beautiful equation on the blackboard. You can build a model that sounds very reasonable. But in the end, only nature decides what is truly correct. That's why I find cola so fascinating. It wasn't just a deep hole. It was the moment the planet began to answer back to human assumptions. And what humbles me the most is that we still know so little. All of our understanding of most of the Earth comes from listening to faint vibrations traveling through materials that no one has ever seen directly. Imagine trying to understand an entire ocean just by listening to waves from very far away. That's almost what we're doing with the interior of this planet. Sometimes the signals match the model perfectly. Sometimes they don't match at all. And every time they don't match, science has to adjust itself. Honestly, I think that's the most beautiful thing about the entire process. Humans haven't really conquered the secrets of the Earth. We've only just started to hear a few very small echoes from inside a giant planetary machine that has been operating beneath our feet for billions of years. One of the strangest things the COLA project revealed is that most of our daily intuition about rock is almost completely wrong when going deep enough inside the Earth. Most people think rock is always hard, brittle, and stable. That makes sense because all our experiences on the surface show that. You hit a rock with a hammer and it cracks. Rocky mountains look motionless and solid, but this is what nature always likes to do to humans. It makes things that seem obvious start behaving very differently when conditions become extreme enough. At depths of kilometers underground, where temperature and pressure increase to enormous levels, rock begins to deform slowly instead of fracturing like on the surface. It no longer behaves like a brittle material. It starts to resemble a giant ductile material, moving very slowly. I know this sounds quite unbelievable, because when we think of rock, we never associate it with anything soft or flowing. But remember that many things in nature depend entirely on time and physical conditions. For example, window glass at room temperature looks absolutely hard and solid, but if heated enough, it will flow like honey. Deep rocks is similar, not because it becomes completely liquid, but because pressure and temperature begin to change how the crystals inside it respond to force. Deep rock layers can bend slowly instead of breaking suddenly. This is why in geology you can see ancient rock layers bent into giant wave shapes as if someone had bent them while they were still soft. The interesting thing is that before the Kola project, many engineers still thought quite intuitively that deep drilling was simply a matter of making stronger equipment. But then they began to realize that the hole was living in some way. The deeper they went, the more the borehole was continuously squeezed by the surrounding rock. Imagine trying to keep a small tube open inside a block of hot material that is slowly tightening around it. That's almost exactly what happened underground. This made drilling increasingly difficult, even though much of the equipment was still working correctly. The problem was no longer simply whether the drill bit was strong enough. The problem was that the entire surrounding environment began changing continuously under extreme conditions. There were times when the engineers pulled the drilling system up and discovered that many parts had bent slightly or deformed. Some drill bits got completely stuck because the deep rock began to soften and grip the system like a giant clamp. This sounds almost absurd if you're only familiar with thinking about surface rock on Earth. But at great depths, familiar physical laws begin to produce very different results. I've always liked using the hot taffy example for this. When cool taffy is hard and brittle, you can break it easily. But when heated, it begins to stretch, bend, and flow slowly instead of cracking. Deep rock behaves somewhat similarly, except the process happens much more slowly and under the enormous pressure of an entire planet. This is the part where I think human imagination often can't keep up with nature. We are used to living in a world with relatively stable temperature and pressure, so our brains start to believe that matter must always behave in familiar ways. But when you go deep inside the Earth, you step into an environment that almost belongs to a different planet. Even the concepts of solid or liquid are no longer as clear as normal intuition. A material can look solid on a timescale of a few seconds, but flow on a timescale of millions of years. This is really important because the Earth's mantle operates exactly like that. It is solid enough to transmit seismic waves, but ductile enough to move slowly and drag the continents across the planet. And it was those strange physical conditions that ultimately forced Kola to stop. Not because humans ran out of curiosity, not because they lacked determination, but because deep down, the Earth no longer resembled the familiar world we live in every day. It became an environment where rock can flow, steel can deform, and the entire planet begins to behave in ways that make human intuition almost completely fail. There is one thing that I think would surprise many people. In many ways, drilling deep into the Earth is actually harder than flying into space. It sounds crazy, right? Because when we think of space travel, we usually imagine giant rockets, speeds of tens of thousands of kilometers per hour, and the deadly environment of space. But think about this carefully for a moment. Once a spacecraft escapes Earth's atmosphere, it flies in a near-perfect vacuum. There is no air creating friction. There are no kilometers of material pressing down on the hull. There is no pressure increasing continuously with every meter traveled. In fact, after the extremely violent initial launch phase, many parts of a space flight actually take place in a much calmer environment than what happens below the Earth's crust. What about the drill bit at Kola? It had to fight everything at once. Temperature increasing continuously, pressure increasing continuously, friction increasing continuously. And the worst part is that everything became more difficult with every kilometer descended. In space, the farther you go from Earth, the less the atmosphere affects you. But underground, the deeper you go, the harsher the environment becomes. I think this is the part where human intuition often underestimates our own planet. We have lived on the surface for so long that we start to believe Earth is a familiar and accessible place. But in reality, the thin crust where we exist is only like the outermost skin of a giant, extremely violent, and hot physical machine inside. The deeper you go, the more mechanical equipment operates near the limits of its materials. Try to imagine a steel column many kilometers long hanging down into the Earth. Just its own weight is already enormous. Now add temperatures over 180 degrees C. Add the pressure of kilometers of rock above. Add continuous friction between metal and rock. The entire system starts to resemble an extreme physics experiment more than an ordinary machine. This creates countless problems that most people have never thought about. A simple example, how do you transmit mechanical energy down tens of kilometers without breaking the system? It sounds simple to say, rotate the drill bit. But in reality, you are trying to transmit rotational motion through a terrifyingly long chain of steel pipes under continuously changing heat and pressure conditions. Just that alone is already an engineering nightmare. Then there's the cooling problem. Friction generates heat. Heat weakens materials. Electronic equipment starts to lose stability. Drilling fluid has to be pumped continuously down many kilometers to reduce friction and bring rock fragments up to the surface. But when the temperature gets too high, even that fluid starts to work less effectively. There were times when the engineers had to continuously change materials and drilling methods just to adapt to the increasingly extreme conditions below. Some types of steel worked well at one depth but failed at another. Some drill bits handled heat well but couldn't withstand long-term pressure. And this is the part I always find very interesting in engineering science. Sometimes nature doesn't destroy you with a big disaster. It just slowly pushes every material to its limit until the whole system starts to fail bit by bit. This also reveals a very humbling truth about our planet. Humans often think space is the harshest environment imaginable, but the deep interior of the Earth is extreme in its own way. We are living on a thin layer of rock covering an entire hot, compressed, and continuously moving world below. And when we try to go down there, we discover that this planet is much harder to access than its normal appearance suggests. I've always liked this paradox. Humanity set foot on the moon before reaching the mantle of our own Earth. Think about that for a moment. We built giant rockets, flew hundreds of thousands of kilometers through space, and landed on another celestial body. But we still couldn't pierce through the thin crust beneath our feet. In a sense, the physical distance to the moon is much greater, but the technological distance to go deep into the Earth is harder to overcome. And I think that says something very important about nature. The most familiar things sometimes contain the hardest to access secrets. What I like most about the COLA project is that it shows us how science really works. Many people think science is the process of finding answers, and eventually everything becomes clearer and more complete. But very often, especially in projects like this, what happens is almost the opposite. The COLA borehole answered some old questions, but at the same time it created even more mysteries than before it began. And honestly, that is the sign of truly interesting science. One of the biggest mysteries remains the amount of water found at depths of kilometers below solid rock. Scientists have fairly good hypotheses about that. They believe the water was released from minerals under extreme pressure, rather than seeping down from the surface. But having a reasonable hypothesis is not the same as understanding completely. We still don't know exactly how much water is deep inside the Earth or how it is distributed in the crust and mantle. This is extremely important because water affects almost every geological process: earthquakes, volcanoes, tectonic plate movement, even the way rock melts beneath the mantle. In other words, water doesn't just exist on the planet's surface in the form of oceans. It may be a very important part of the entire geological machine inside the Earth. And the more we research, the stranger everything becomes. Some rock structures discovered at COLA are still difficult to explain completely with current models. There are rock layers that behave differently from predictions. There are mineral changes that don't fully match what scientists thought would happen at those temperatures and pressures. This is what I always find very interesting in physics and geology. Nature is often not wrong in the way humans think. Instead, it shows that our models are still incomplete. And then there's the temperature issue. This was truly a big shock. The engineers and geologists had fairly detailed thermal models before drilling began. They calculated how temperature increases with depth and believed they understood the process quite well. But the reality deep below was much hotter than predicted. This might seem like just a small technical error, but in fact it carries much greater significance. If we miscalculated the temperature at just over 10 kilometers depth, then how reliable are our models for hundreds or thousands of kilometers deeper? It shows that we still don't fully understand how heat moves inside the Earth. We know about conduction, convection, and radioactive decay, but the way all those processes combine inside a giant complex planet is far more complicated than simple models on paper. And this is the part that always makes me feel a bit strange in a very beautiful way. Humans built one of the most ambitious engineering projects in history, drilled deeper than anyone had before, using decades of technology, resources, and intelligence. But in the end, we had only touched the outermost layer of the planet, like someone trying to understand the structure of an entire apple by scratching the outer skin. In a sense, COLA not only showed how mysterious the Earth is, it also showed the smallness of human knowledge compared to the true scale of nature. I think this is the part many people misunderstand about science. They think that if a model is proven not entirely correct, it is a failure. But in science, sometimes the most valuable result is precisely discovering that the old model was wrong or not good enough, because that is how knowledge advances. If Kola had only confirmed all the initial predictions, this project would have been far less interesting. What makes it important is that it forced scientists to re-ask questions about things that were once considered fairly certain. Granite did not turn into basalt at the predicted depth. Temperature did not increase at the expected rate. Water existed where it shouldn't have been able to exist. Rock behaved differently from ordinary intuition. Each surprise was like the earth whispering to humans, "You don't understand me as much as you think you do." And really, we don't understand that much. What fascinates me the most is that Kola only went down about 12 kilometers, while the Earth's radius is about 6,000 kilometers. Think about that ratio for a moment. We haven't even really started the journey into the interior of the planet. This opens up an almost unavoidable question. If at such a shallow depth nature is already strange enough to break many scientific models, then what about even deeper? Below the mantle, hundreds of kilometers deep, there may exist states of matter we have never seen. Pressure may create completely different crystal structures. Temperature and matter may interact in ways that no simulation has accurately described. And that is what makes me think the Kola project didn't really end when drilling stopped. In a sense, it only opened the first door leading into a world below that we still know almost nothing about. Perhaps at this point, you have heard one of the most famous stories surrounding the Kola super-deep borehole. The story claims that Soviet engineers once lowered a microphone to the bottom of the hole and heard horrible screams echoing up from deep inside the earth as if they had drilled into hell. Honestly, this is the kind of story that the human brain can almost not resist. The deepest hole in human history, located in the desolate Arctic region, going deeper than anyone had gone before. It already sounds enough like the beginning of a science fiction movie. So when the Sounds from Hell story began to spread in the late 20th century, tabloid newspapers and mystery television programs latched onto it immediately. It spread around the world at an astonishing speed. Many versions even claimed that the engineers panicked and fled the site after hearing the terrifying sounds coming from the earth. But this is the part I think is very important to make clear. There is no reliable scientific evidence confirming that story. There is no verified original audio recording. There is no official scientific document from the Kola project mentioning the discovery of hell sounds. Most of the story seems to originate from radio programs and sensational articles that were exaggerated over time. And honestly, this doesn't surprise me at all. Humans have a tendency to create myths whenever they face things that are too big, too deep, or too mysterious. We have been doing this for thousands of years. The oceans was once full of sea monsters in human imagination before science understood them better. Volcanoes were once seen as gateways to the underworld. Solar eclipses once made many civilizations think the gods were angry. When we encounter something beyond current understanding, our brains almost automatically try to fill the gaps with mythology. And I think that is quite interesting from a psychological perspective. But honestly, I've always found the scientific reality far more fascinating than supernatural stories. Think about it. We are talking about a project where humans actually drilled more than 12 kilometers into the Earth's crust. They found water where it shouldn't have been possible. They discovered that long-standing geological models weren't entirely correct. They witnessed rock behaving like a ductile material under extreme temperature and pressure. Just those things alone are strange enough. We don't need to add demons or screams to make the story more interesting. In fact, sometimes I think legends like that take away from the real beauty of science. Because the most astonishing thing is not what is imagined, but what nature is really doing beneath our feet. A planet with a liquid metal core creating a magnetic field. A hot rock mantle moving slowly and dragging continents across the globe. Radioactive elements quietly warming the planet for billions of years. Water locked deep inside minerals under enormous pressure. Honestly, reality is already stranger than most science fiction. I think this is also very important in science, distinguishing between the feeling of mystery and the feeling of supernatural. Science does not destroy the wonder of the world. It only replaces imaginary stories with truths that are even stranger. And the best part is that those truths are real. They exist whether humans believe in them or not. Kola is the perfect example of this. A small hole on the Earth's surface was enough to make the scientific community re-examine many assumptions about the planet. It showed that we still understand very little about the deep interior of the world we live in. In my opinion, that is what is truly astonishing. Not the idea of hell lying beneath the earth, but the fact that this planet still contains countless things we cannot understand, even though we have entered the modern technological age. And perhaps that is what keeps humans drawn to Kola. Not because it leads to any supernatural world, but because it reminds us that right beneath our feet still exists a world that is almost alien dark and far more mysterious than what our daily intuition leads us to believe. There is one idea that I've always found very interesting, even though it sounds a bit strange at first. In many ways, the Earth behaves more like a giant living creature than a dead rock mass. Of course, I'm not saying the planet is alive in the biological sense like plants or animals. What I mean is that it is always moving, always changing, always exchanging energy, and has almost never truly stood still since it formed. But human intuition makes it very hard to sense that, because we live far too short compared to geological time. A mountain looks motionless throughout a human lifetime, so the brain starts to believe it is permanent there. A continent looks stable, so we think it is fixed forever. But if you could speed up time by millions of years, like fast-forwarding a movie, the Earth would look amazingly alive. Continents would move. Oceans would open and close. Mountains would rise and then erode away. Volcanoes would erupt continuously. The entire planet's surface would look more like an ever-changing system than an immobile rock mass. All of that happens because the mantle beneath the crust does not stand still. It moves extremely slowly under the influence of heat and convection. Hot rock from deep below rises, cooler rock sinks, creating giant convection currents that last for millions of years. And it is that movement that drags the tectonic plates on the planet's surface. This sounds strange because we usually think continents are fixed to the Earth. But in reality, they are more like giant rafts of rock floating on the mantle. In a sense, the crust where we live floats on the layer below like thin ice floating a cold ocean. The only difference is that here the ocean is hot rock moving slowly. I've always liked this reversal of intuition. The things that look the hardest and most stable turn out to be moving over millions of years without us even noticing. Mountains, earthquakes, and volcanoes are really just surface signs that the machine inside the planet is still operating continuously. When tectonic plates collide, mountains are raised. When they slide past each other or get stuck and then release energy, earthquakes occur. When the hot mantle pushes molten material to the surface, volcanoes erupt. In other words, the interior of the Earth has never truly cooled or fallen silent. It is still operating as it has for billions of years. What makes me find this especially interesting is that today's continents were once in completely different positions in the past. North America and Europe were once joined together. Antarctica was not once at the South Pole. India was once a separate island before crashing into Asia and creating the Himalayas. The continents have moved thousands of kilometers throughout the planet's geological history. If you look long enough, the Earth resembles a giant puzzle game where the pieces never stop drifting. And this is where Kola becomes truly wonderful to me. The fossilized microorganisms found deep beneath the Kola Peninsula are evidence that the place now located in the icy Arctic region was once at the bottom of an ancient ocean, hundreds of millions of years ago. Think about that for a moment. A cold place near the Arctic today was once under a warm ocean in the planet's distant past. This could only happen because the entire surface of the Earth is always moving and changing over time. I think this is one of the hardest things for the human brain to grasp. We are used to thinking the world is stable because all geological changes happen too slowly compared to a human lifetime. But on a scale of tens or hundreds of millions of years, this planet is almost never still. Oceans disappear. Mountains rise and wear down. Continents split apart and collide. Even the global atmosphere and climate change continuously. And all of that originates from the enormous energy still moving deep inside the Earth. In a sense, we are living on the surface of a giant dynamic physical system that humans mostly fail to notice most of the time. What I like most about science is that it completely changes the way you look at the things that seem most familiar. A mountain is no longer just a motionless pile of rock. It is the result of tectonic forces raising the crust. An earthquake is not just a random disaster. It is energy accumulated from the slow movement of tectonic plates over centuries. Even the ground beneath your feet is not truly fixed in the absolute sense. And that is why I think the Earth is not a static stage where life takes place. It is a complex, hot, moving, and almost always changing dynamic system from the very first day it formed in the early solar system. What makes me always respect the Kola project is not that humans failed, but that it shows there are real physical limits that nature sets for all the technology we create. This is not a story about lacking money, lacking determination, or lacking intelligence. The engineers and scientists involved in this project basically devoted their entire lives to trying to go deeper into the Earth. The issue was that the deeper they went, the more they discovered that nature was playing by completely different rules from the familiar world on the surface. One of the most important things Kola showed is that every material humans create changes its properties when temperature and pressure become high enough. We usually think steel is almost indestructible. Skyscrapers, warships, giant bridges, and even rockets all rely on it. But kilometers deep in the Earth's crust, even steel begins to behave differently. It expands due to heat, gradually loses its hardness, deforms under enormous loads, and can ultimately fail in ways that are very hard to predict. This happened to almost every part of the drilling system. The drill bits wore out much faster than calculated. The kilometers-long drill pipes began to bend slightly or twist under enormous pressure. Electronic equipment became unstable when temperatures exceeded design limits. Even the sensors used to measure deep data struggled in that extreme environment. I think this is something many people don't realize about engineering. When you build a machine for normal conditions, physics is fairly forgiving. But when you push everything to the limits, physics starts to become very unforgiving. A small error can turn into a disaster. A material that works perfectly on the surface can fail completely at depth. And the interesting thing is that the Kola engineers didn't just have to drill down. They also had to keep an entire system operating stably at depths of tens of kilometers. For example, just pumping drilling fluid down and then bringing it back up to the surface was almost a gigantic problem in itself. That fluid wasn't only used for cooling. It also helped reduce friction, keep the borehole walls stable, and bring the cut rock fragments up. But when the temperature rose too high, the fluid began to change properties. Its viscosity changed, cooling efficiency dropped. The pressure below made circulation much more difficult. You can imagine the whole system like trying to keep blood circulating steadily in a giant body that is being heated and squeezed tightly from all sides. What fascinates me is that even though today's technology is far more advanced, many of the problems Kola faced still haven't been completely solved. We have better materials, more powerful computers, and more accurate simulations, but the basic limits of temperature, pressure, and materials remain. That's why no one has truly drilled significantly deeper than Kola. In many ways, this project still stands at the final frontier of modern deep drilling technology. And I think that says something very interesting about nature. Nature doesn't care about human ambitions. It doesn't care how smart we are or how confident we feel. The laws of physics simply exist as they are. If steel softens at high temperatures, it will soften regardless of what you want. If the pressure is great enough to make rock flow slowly like a ductile material, it will do so no matter how unreasonable humans find it. In a sense, science is the process of learning to accept that reality instead of trying to impose our own intuition onto nature. I've always thought this is the most beautiful part of real science. It makes humans humble. Every major step forward usually comes with recognizing new limits we hadn't seen before. When humans learned to fly, we discovered the limits of speed and aerodynamics. When we built nuclear reactors, we faced the limits of materials and radiation. And when we drilled into the Earth, we began to confront directly the heat, pressure, and material structure of the planet itself. That makes me feel that Kola wasn't just a geological project. It was like a giant test of the limits of human technology, an experiment to see how far humans could go before nature said, "This is as far as you go." And the interesting thing is that even though it ultimately had to stop, the project still succeeded in its own way. Because sometimes the greatest value in science isn't in overcoming every limit, but in discovering where the real limits of the world actually are. Honestly, if all Kola had achieved was setting a depth record, it probably would have become an interesting footnote in engineering history and gradually been forgotten over time. But what keeps scientists still talking about it decades later is the data it provided about our own planet. In many ways, Kola was like the first time humans truly sampled a deep part of the Earth's crust instead of just guessing from a distance. Before this project, most of our understanding of the planet's interior came from seismology, analyzing how earthquake waves travel through different material layers. But Kola allowed scientists for the first time to directly compare seismic models with real material brought up from depth. That was extremely important. It was like finally getting the chance to check whether the map you drew from radar signals actually matched the real terrain. And as we saw, many things didn't match perfectly. Data from Kola helped scientists better understand how seismic waves respond to different types of rock under extreme temperatures and pressures. This is important not only for geology, it also affects how we study earthquakes, continental structure, and even the planet's formation history. I've always liked the idea that a small hole in the Arctic could change the way humans view the entire Earth. One of the most interesting parts of the project was the rock samples pulled up from depths of kilometers. Those rock cores weren't just ordinary rock. In a sense, they were like ancient diary pages of the planet. Every mineral layer, every chemical trace, every fossilized microorganism told part of a history that happened hundreds of millions or even billions of years ago. I've always found this almost magical. We usually think history only exists in books or human-made ruins, but in reality, the Earth itself preserves its history inside deep rock. Samples from Kola helped scientists better understand how the continental crust formed and changed over time. They showed that many areas were once under ancient ocean floors before being uplifted and moved over millions of years of tectonics. These studies also improved our understanding of earthquakes. By better understanding the properties of materials beneath the crust, scientists can build better models of how seismic energy propagates through the planet. This is very important because earthquakes are not just random phenomena. They are direct results of forces moving inside the Earth. Kola also changed how the scientific community thinks about deep water. Previously, many people viewed water mainly as a surface phenomenon. Oceans, rivers, lakes, rain, and shallow groundwater. But the discoveries at Kola showed that water can exist much deeper inside the crust in forms completely different from ordinary intuition. This changed how we understand rock melting processes, volcanic activity, and the material cycle inside the planet. And then there's the temperature issue. Kola showed that the Earth's interior is much hotter than predicted in some areas. This forced scientists to re-examine many models of how heat moves in the crust and mantle. What I like most is that this project didn't simply confirm what humans already knew. It continuously pointed out where current understanding was still lacking. To me, that is what truly interesting science looks like. Many people think science is the process of collecting more and more correct facts. But in reality, science often advances most strongly when we discover where we were wrong. I've always said that the most interesting moment in the laboratory is not when someone says, "I was right," but when someone looks at the data and says, "Wait, this isn't what we thought." It is exactly that moment that opens the door to new understanding. And Kola was full of such moments. That's why even though the project ended long ago, much of the data and samples from Kola are still being studied to this day. Geologists still return to them to test new hypotheses, new models, and new analysis technologies. In a sense, that hole is still not silent. It continues to speak to science about the history of the Earth. What is truly astonishing is that to this day, the Kola super deep borehole remains the deepest borehole in human history. Think about that for a moment. Humans have built supercomputers, constructed space stations, sent robots to Mars, and probes to the edge of the solar system, but the deepest hole we have ever drilled into our own planet is still a project started in the early 1970s during the Cold War. There is something very strange about that. A small hole on the Earth's surface, almost invisible if viewed from space, represents the deepest limit that humanity has ever reached inside the planet we live on. I've always found that idea both humbling and beautiful. We often think modern technology can do almost anything if given enough time and money. But Kola is a reminder that nature still has boundaries that humans cannot easily cross. After Kola, many other drilling projects tried to break that record. Oil companies developed ultra-deep drilling technology. Modern drilling rigs have far more advanced computer systems than in the Soviet era. Some boreholes have a total length even longer than Kola due to horizontal or angled drilling. But when it comes to true vertical depth straight down into the Earth's crust, Kola still holds the record. And the reason is very simple. The basic physical problems still don't disappear. Temperature still increases. Pressure still increases. Materials still change properties. Rock still continues to behave strangely at extreme depths. In many ways, modern technology only helps us manage those problems a little better, but hasn't truly overcome them. This also reveals a very interesting truth about engineering. Many people think technological progress always moves in a straight line. Computers get faster. Engines get stronger. Materials get better. But there are fields where every new step becomes exponentially more expensive and complex. Coal is the perfect example of that. The deeper you go, costs and difficulties don't just increase a little. They explode almost unreasonably. You need stronger equipment to withstand heat. Stronger equipment needs more power. The cooling system must be better. Materials must withstand higher pressure. Drilling fluid must perform more stably. And then everything fails again under even harsher conditions. It's like trying to climb down a well whose walls keep getting hotter, narrower, and tighter around you. I think this is where humans begin to feel the true fragility of technology compared to the scale of the planet. We are often very proud of the machines we create, and honestly, we have reason to be proud. But Kola shows that no matter how impressive the technology is, it still exists on an extremely thin crust of a planet much larger than us. In a sense, humans are like tiny creatures trying to use metal tools to touch a giant geological machine that has been operating for billions of years. And the deeper we go, the more we realize that machine is far more powerful than we thought. What I like most is that Kola was never really just a technical competition. If the goal was only to set a record, this project wouldn't have such lasting appeal. What makes it special is that it represents something very human curiosity. There is something almost primal in the desire to look down beneath our feet and ask, what's down there? In many ways, Kola shares the spirit of the first explorers who crossed oceans, or the astronomers who looked at the sky through primitive telescopes, not because they were sure they would find something, but because they couldn't resist the need to know. I think that is the real reason this project still fascinates people today. It is not simply an old abandoned technical project in the Arctic. It is a symbol of the moment when humans tried to look deeper into their own planet and discovered that the world below was far stranger than imagined. Today, if you go to the Kola Peninsula in the far north of Russia, it is very hard to believe that the place was once the center of one of the most ambitious scientific projects in human history. The surrounding area is almost completely abandoned in the freezing Arctic climate. Wind blows through old concrete structures. Snow covers rusted metal framework. There is no longer the sound of engines, no longer the rumble of drills shaking the ground, no longer groups of engineers working day and night like decades ago. What I always find strange is that places that once represented the peak of human scientific ambition sometimes end in such silence. The giant drilling rig that once operated continuously for 24 years now has only old steel frames and cracked concrete foundations due to harsh weather. If you didn't know the history of this place in advance, you might pass by and think just some abandoned industrial site in the Arctic. But right beneath that ground is the deepest point humans have ever reached in all of history. And what haunts me the most is the smallest thing at this site. The mouth of the borehole is now sealed with a metal cap welded tightly to the ground. Just a simple round metal plate sitting in the cold wilderness. At a glance, it looks almost unremarkable. But right beneath that cap is more than 12 kilometers going down into the Earth's crust. I've always thought it looks like a door that has been closed in front of the planet's secret. A very small door, but one leading to the deepest place humanity has ever tried to enter. The interesting thing is that most of the world has almost forgotten this place exists. When people talk about the great scientific achievements of the 20th century, they usually remember the Apollo spacecraft, particle accelerators, or space telescopes. But Kola is rarely mentioned, even though it was one of the boldest direct efforts to explore the very planet we live on. Perhaps because there were no spectacular images like a spacecraft launching, no astronauts walking on the moon, just a small hole in a cold land. But honestly, I think that actually makes the story more beautiful. It has a very human feel, not glamorous, not Hollywood epic. Just a group of engineers and scientists spending decades trying to look deeper into the world beneath their feet. There's something a bit sad, but also very majestic in imagining that place now completely silent. I sometimes think about all the people who once worked at Kola. The young engineers who started the project in the 1970s and grew old along with that hole. The geologists standing in the Arctic cold, waiting for each rock sample to be pulled up from depths no one had ever reached. The scientific debates that took place in the middle of the night about the strange data just obtained. And then finally, everything stopped. The machinery was dismantled. The site was abandoned. Snow began to cover everything. In many ways, the history of science is full of places like that. Laboratories that once changed how humans understood the world and then gradually fell silent after their era passed. But that doesn't mean they lost their meaning. Kola still lies there as a physical trace of human curiosity. A small hole on the surface, but containing inside it an entire story of ambition, technological limits, and the unanswered secrets of the Earth. And I think that is the perfect image to end this part. A nearly forgotten cold land in the Arctic. Beneath the snow and ice is a deep hole lying silent in the darkness. But somewhere more than 12 kilometers down there still exist questions that humans have never fully answered. What perhaps amazes me the most after the entire Kola story is realizing that even though we have studied the Earth for centuries, most of the interior of this planet is still almost unexplored territory. We live here, build cities, dig tunnels, mine, and walk on the surface every day. So the brain starts to create the feeling that we understand this planet quite well. But in reality, if we look honestly, human direct knowledge of the deep interior of the Earth is extremely limited. We have never seen the mantle with our own eyes, never taken samples directly from the outer core, never touched the inner core, The vast majority of the planet's structure that science describes is actually inferred from indirect signals and physical models. This sounds a bit crazy if you stop and think about it for a moment. We can photograph galaxies millions of light years away, but we still cannot directly see the layer of material lying a few dozen kilometers beneath our feet. Most current understanding of the Earth's interior comes from seismology, mathematical models, and high-pressure physics experiments in laboratories. Scientists create seismic waves from earthquakes and analyze how they travel through the planet. They simulate enormous temperatures and pressures with special equipment to predict how matter will behave at depth. They study meteorites to infer the composition of the Earth's core, because some meteorites have structures similar to the primitive material of the early solar system. In many ways, we are piecing together a giant picture from millions of small data fragments without ever truly seeing the whole picture directly. And what makes everything even more fascinating is that many scientists believe that even deeper down there may exist states of matter we still don't fully understand. Under the enormous pressure of the deep mantle and the planet's core, atoms may arrange into structures very different from the familiar matter on the surface. Some minerals only exist under the extreme conditions inside the Earth. There are forms of ice that exist at high pressure that are completely different from the ice we see in the refrigerator. There are hypotheses about how metals behave at temperatures and pressures so great they are almost impossible to perfectly recreate on the surface. This always makes me feel that the planet beneath my feet is no less mysterious than outer space. Honestly, sometimes I think humans tend to look up at the sky to find wonder and forget that the deep part beneath our feet is also as alien as another planet. We talk about black holes, galaxies, and worlds outside the solar system as the most mysterious places in nature. But the mantle and core of the Earth are also strange in their own way. A hot rock ocean moving slowly, a layer of liquid metal creating the planetary magnetic field, a solid iron core nearly as hot as the surface of the sun. All of that exists right beneath the thin layer of rock where we live every day. And what I like most is the feeling of humility that science brings when you truly understand the scale of nature. Humans are often very confident in their technology and knowledge, and that is understandable. We have achieved astonishing things. But then a project like COLA appears and reminds us that we have only just begun to understand our own planet. I think that is a very important feeling in science. Not the feeling that we know everything, but the feeling that there is still so much we don't know. To me, that is what keeps science alive, because every major discovery almost always creates many more new questions. When COLA found water at depth, scientists had to ask where the water came from. When the temperature was higher than predicted, they had to ask what was happening with the heat transfer process inside the planet. When granite did not turn into basalt, as the old model predicted, they had to re-examine how seismic data is interpreted. Every time we answer one question, nature opens up several more even bigger mysteries behind it. And honestly, I think that is the most beautiful thing in the entire scientific journey. If everything were easy and every question quickly had a perfect answer, science would lose its most interesting part. What keeps humans continuing to explore is the feeling that out there, or more accurately, down there, there is still so much no one fully understands. COLA showed us a very small part of the world inside the Earth. But at the same time, it showed how long that journey of discovery still is. Many people think science is the process of proving yourself right. But honestly, the most interesting moments usually happen when nature suddenly tells us, nope, things don't work the way you think they do. I always feel excited whenever an experiment produces results that don't match the initial prediction, because that is often a sign that you're standing in front of something new. And COLA was almost entirely built from moments like that. The scientists entered the project with quite a few very reasonable sounding models. They thought they understood how temperature increases with depth. They thought they knew where granite would turn into basalt. They thought water couldn't exist under such extreme pressure. But then the reality underground began to surprise them continuously. To me, that is the most beautiful part. COLA is fascinating not because it confirmed everything humans already knew, but because it proved that nature is far more complex than the models we create on paper. I think this is something important that people sometimes forget when talking about science. A scientific model is not absolute truth. It is simply the best way humans currently have to describe nature based on the available data. And when new data appears, the model has to change. That doesn't make science weaker. On the contrary, that is science's greatest strength. I've always loved the feeling when real data forces scientists to rethink things. Imagine spending years being absolutely certain about something, and then one day, a rock sample pulled up from kilometers deep makes that entire assumption start to shake. There is something very alive in that moment. It's like nature tugging at your sleeve and saying, wait, you haven't seen the whole picture yet. The interesting thing is that many major advances in the history of science started from results that sounded unreasonable. In physics, light behaving, both like a wave and a particle, sounded extremely absurd to ordinary intuition. But from that, quantum mechanics was born. In astronomy, galaxies rotating too fast compared to the observed amount of matter led to the idea of dark matter. In geology, the surprises from Kola forced scientists to re-examine how they understood the Earth's crust. I think nature often advances by confusing us first. And that is why I've always believed that doubt and curiosity are at the center of real science, not absolute certainty. Not the feeling of, I already understand everything. Honestly, the most dangerous moment in science is usually when humans start thinking they have completely understood a complex system, because that's when we stop asking questions. I've always liked the image of a good scientist being more like a curious child than someone trying to prove how smart they are. A child looks at the world and keeps asking why, without feeling ashamed of not knowing the answer yet. To me, that is the most beautiful spirit of science. And Kola carried exactly that spirit. A group of people decided to drill deep into the earth, not because they were sure they would find something, but because they wanted to know. It's really as simple as that. I think this is also why projects like Kola still captivate people even after many decades have passed. It touches something very basic in our minds, the need to explore the unknown. Not to completely control nature, but to understand it a little more deeply than before. What I hope people take away from this story is not just the number 12 kilometers or the interesting geological facts. I hope it's the feeling of curiosity, the feeling that even the familiar planet beneath our feet still contains countless things no one fully understands. I think keeping that kind of curiosity is extremely important, because the moment humans start thinking they have completely understood the world is exactly when real exploration stops. There's one thing I've always found both humorous and strange about humanity. We have sent spacecraft to Mars, flown past Jupiter, landed robots on Saturn's moon Titan, and even have devices now leaving the solar system heading into the space between the stars. We have photographed galaxies billions of light years away. We can look at star explosions that happened before the Earth existed, but at the same time, we have never directly seen the mantle of the very planet beneath our feet. Honestly, if you think about it carefully, that is almost absurd. Humans can observe objects at unimaginable distances in outer space, but we still can't pierce the thin crust of the world we live on. I've always liked this irony. The planet most familiar to us turns out to contain regions that are almost as alien and mysterious as any world out in space. Perhaps it's because when we look up at the sky, the mystery appears very obvious. Distant planets, glowing nebulae, and giant galaxies naturally make humans feel they are facing the unknown. But the ground beneath our feet is different. We walk on it every day, so the brain starts to think it is familiar and well understood. Kola is a very powerful reminder that that feeling is largely an illusion. Beneath the thin layer of soil where we build cities and live our daily lives is an entire world that humans have almost never seen directly. I think this is something very interesting in the history of science. Humans are often drawn to things that are very far away. We point telescopes at the sky, send spacecraft into space, and dream about other galaxies. But sometimes the greatest mysteries lie right beneath our feet. In many ways, the mantle and core of the Earth are even more alien than the surface of Mars. We have extremely detailed maps of many areas on Mars. We have high-resolution images of craters on the Moon. But most of the Earth's interior still exists mainly as mathematical models and indirect signals. This always makes me feel both amazed and humbled, because it shows how strongly human perception is limited by physical conditions. Just because something is close doesn't mean it's easier to explore. Space is very far, but its vacuum is sometimes easier to deal with than the enormous temperatures and pressures beneath the planet's crust. In a sense, the Earth protects its secrets very effectively. It covers the deep interior with dozens of kilometers of hot rock, extreme pressure, and conditions that make human materials start to fail. And that is exactly what makes Kola so special to me. It reminds us that exploration doesn't only exist in distant space. It also exists right here, on the very planet we thought we were already too familiar with. I think many people imagine modern science like a journey where humans are gradually completing the map of the world. But my feeling is almost the opposite. The deeper we explore, the more we realize how little we know. When we look at the universe, we discover that ordinary matter makes up only a small part of the entire cosmos, with the rest being dark matter and dark energy that no one fully understands. When we look at the Earth, we discover that most of the planet's interior has still barely been touched directly. When we study quantum physics, we discover that nature is far stranger than human intuition. To me, that is not a sign of failure. It is a sign that nature is richer than our imagination. And honestly, I find that very beautiful, because it means the mystery has never truly disappeared from the world. It just changes location. There was a time when humans thought the mystery lay in unexplored oceans. Then the mystery moved up to the sky with the planets and stars. But even today, in the age of satellites and supercomputers, there are still regions that are almost alien right beneath our feet. I think Kola is the perfect symbol for that. A small hole in the Arctic was enough to remind humanity that the planet we live on is not simple or fully understood. And perhaps that is the most wonderful thing about science. It doesn't make the world smaller or less mysterious. It only continuously shows us that in every direction we look, whether up at the distant sky or deep down into the earth, nature is still far greater than anything humans have ever imagined. Let's return to the opening image one more time. You stand at the edge of a hole on Earth, drop a rock down, and nearly a minute later hear the sound of impact echoing up from the deep darkness below. Just that idea alone is already enough to make the human brain feel strange. A hole so deep that sound takes nearly a minute to return. And what is even stranger is that even though it is the deepest borehole in human history, even though humans spent decades, used giant machines and the most advanced technology of that time to create it, we still haven't pierced through the entire thin outer crust of the Earth. If this planet were shrunk down to the size of an apple, Kola wouldn't even have gone through the apple's skin. In a sense, this whole story is a wonderful lesson in humility. We have lived on this planet since birth, so the brain starts to create the feeling that it is familiar, stable, and mostly well understood. But Kola reminds us that most of the Earth is still almost unexplored directly. We have only lightly touched the surface of a world thousands of kilometers deep that is hot, moving, and continuously active beneath our feet. And what I like most is that every time humans think they understand something quite well, nature brings another surprise. Scientists once thought granite would turn into basalt at a certain depth, but that didn't happen. They thought water couldn't exist under that extreme pressure. But the water was still there. They thought temperature would increase according to the familiar model. But reality was much hotter than predicted. To me, that is the most beautiful part of science. Not the feeling of we've understood everything, but the moment nature makes us realize the real picture is far bigger than we thought. I've always thought scientific models are more like maps than the actual territory. A map can be very beautiful, very useful, and very accurate in many cases, but it is never the entire real world. And sometimes a small hole in the Arctic is enough to remind us that the real territory is always more complex than the map. That doesn't make science weaker. On the contrary, that is what makes science alive. Because if everything were already clear, there would be nothing left to discover. Honestly, what has always made me love science has never been the feeling of absolute certainty. What fascinates me is the feeling that there is always something unknown out there. A new question, strange data, a result that doesn't match the old model. Those are exactly the things that pull science forward. And Kola is the perfect example of that spirit. It didn't give humans all the answers. It only opened a small door down into the earth and showed us that the world inside is far stranger than we initially imagined. I think this is also something very human in the whole story. Even when facing failure, even when equipment was destroyed, even when heat and pressure ultimately defeated the technology of that time, humans still kept trying to look deeper. Not because they were certain of success, but because of that almost unquenchable curiosity. To me, curiosity is one of the most beautiful things humans possess. It makes us look up at the sky and build telescopes. It makes us split atoms, study DNA, and send spacecraft outside the solar system. And it also made a group of engineers in the Arctic decide to drill deep into the earth just to answer a very simple question. What's down there? The wonderful thing is that question still doesn't have a complete answer yet. We still haven't seen the mantle with our own eyes. We still haven't touched the planet's core. We still don't fully understand how heat, pressure, and matter behave inside the earth. And I think that is truly great, because it means nature still keeps secrets for future generations to continue exploring. Perhaps what moves me the most in the entire Kola story is the feeling of being both small and lucky. Small because we realize this planet is far larger and more complex than we are. But also lucky because we get to live in a universe that still has things we don't know. A world where, even beneath our feet there, still exist mysteries no one has fully solved. I think many people believe that as science develops, the world loses its wonder. But my feeling is always the opposite. The deeper we understand, the stranger and more beautiful nature becomes. A planet with a liquid metal core creating a magnetic field. Continents drifting slowly on a hot mantle. Water existing deep inside rock under enormous pressure. A small hole enough to force an entire series of scientific models to change. Honest reality is far more wonderful than most science fiction, and perhaps that is the perfect way to end this story. The universe doesn't just lie in the starry sky above our heads. It also exists right beneath our feet, in the dark and scorching rock layers of this very planet. The most important thing is not how deep we have gone or how many questions we have answered. The most important thing is to never lose that feeling of curiosity toward nature, because it is that curiosity that keeps humans discovering, learning, and continuing to look at the world with eyes full of wonder, like a child realizing for the first time that the universe is far bigger than they ever imagined. If you like science stories that make us see the world in a completely different way, please subscribe to the channel and join me in continuing to explore the strangest mysteries of the universe and the planet beneath our feet. And for now, keep that curiosity in your mind, because sometimes the greatest secrets of nature are not out among the stars, but are lying silently right beneath our feet.